Stereochemistry, we can say, is a fascinating element of chemistry. Before I begin with a few concepts of stereochemistry, I would like to mention an incident which threw light on stereochemistry. After the Second World War, it was noted that many children they were born with birth defects. It was found that a pregnant woman in 1950s they were given thalidomide and tablet to prevent morning sickness, that is vomiting, etc. Not all women who are administered thalidomide were fine. Women who were administered the R isomer of thalidomide, they were fine because R isomer it works like a sedative, whereas S isomer it is a teratogen. That is, these women who were administered S isomer, they gave birth to infants with birth defects. This aroused interest in researchers to explore the reason. This particular tragedy has brought stereochemistry to limelight. From then on, stereochemistry has become very vital in research, and more importance is given to the separation of racemic mixture. So, when I say racemic mixture, it is also called as a racemate. It is a mixture of equal quantities of two enantiomers. The stereochemistry is very fascinating and it is very vital in research. So now what is stereochemistry? Stereochemistry we can say is a study of three-dimensional structure of molecules. We can say it is a chemistry that studies the properties of isomers. Stereochemistry is a study of relative arrangement of atoms or groups in a molecule in three-dimensional space. And the properties of many drugs, they depend upon their stereochemistry. For example, ketamine is a drug. It has got two isomers, the R isomer and the S isomer. R isomer is a hallucinogen, whereas S-ketamine, it is an anesthetic. Thus, to summarize, we can say stereochemistry is a study of three-dimensional structure of molecules. Now, let us see what stereoisomers are. These are isomers of the same molecular formula, same bonding sequence, but they have different spatial orientation. I repeat, isomers of the same molecular formula, same bonding sequence, but the different spatial orientation are called as stereoisomers. We can say these are compounds of the same connectivity but different arrangements in space. They are isomers that differ only in the position of atoms in space and that cannot be interconverted by rotation around a single bond. Stereoisomers, they cannot be converted into each other without breaking the bonds. Stereochemical isomers, they are molecules which have same chemical formula and bond connectivity but different relative arrangement in three-dimensional space. In contrast, the constitutional isomers, they have the same molecular formula but they have different bond connectivity. For example, N-butane and isobutane, we can call them as structural isomers, whereas isomers of limonene, the compound which gives different taste to lemon and orange, they are examples of stereochemical isomers. Plus limonene gives orange taste, whereas minus limonene, it gives the lemony taste. Yet another example is that of carvone. Carvone is a naturally occurring compound which is found in caraway seeds. In Tamil, it is called karivepillai. And it is also present in mandarin, orange peel, etc. And yes, carvone, it smells like caraway. Whereas its mirror image is called as R carvone. It is extracted from spearmint. It smells like spearmint. And ginger grass oil that contains mixture of both enantiomers. Now let us see what structural or constitutional isomers are. So the another name for structural isomer is constitutional isomer. Now what are structural isomers? They have the same molecular formula but different bonding sequence. The different order of connections give rise to different carbon backbone or different functional groups. Let us consider three examples. The first example is that of 2-methylpropane and butane. If you take 2-methylpropane, propane we know is CH3, CH2, CH3. In the central carbon CH2, if you replace one hydrogen by methyl group, we get 2-methylpropane. And butane is a straight chain of 4 carbon atoms, CH3, CH2, CH2, CH3. So 2-methyl and propane and butane, they have different carbon skeletons and they are examples of a structural isomer. One more example is ethyl alcohol and dimethyl ether. Both have the formula C2H6O, but ethyl alcohol is CH3CH2OH and dimethyl ether is CH3OCH3. Thus, in ethyl alcohol, the functional group is OH alcohol and dimethyl ether, the functional group is bond O bond ether. And these are also examples of structural isomers. One more example is isopropylamine and propylamine. In isopropylamine, you have the propylamine group in iso position, that is in branched form. Um, CH3, CH, and you have NH2 in CH as a branching, and then you have CH3. Whereas in propylamine, it is as a straight chain CH3, CH2, CH2, NH2. Thus, the functional group amine is in different positions. Thus, all these three examples are examples of structural isomers. Stereochemistry is a study of three-dimensional structure of molecules. Stereoisomers are compounds with the same connectivity but different arrangements in space. And structural isomers, they have the molecular formula same, but they have different bonding sequence or different order of connections, giving rise to different carbon backbone or different functional groups. Thanks for listening.